Hello everyone, this is a follow-up of the previous video that I posted. So basically in this video I'm going to show you guys the timing diagram, integrated timing diagram. Previously I only showed you guys how each individual system worked. So this time I have integrated all the systems, and basically I'm going to show how the fetch, execute and decode cycle is going to work. And then I'm also going to show you guys how the assembler is going to work. So basically this is the assembly program that I have written: load R1 to 30, load and add both of them and store it into R1. And basically you can delete this because you can just do this also. Let's just have a small program so that it will be easier. So let's convert this into assembly. So for now I have put things in memory instance just like this because there were no input output interference. So basically in this step I'm writing the memory manually. Now when I create a Verilog, okay, there are no semicolons because of which there are errors, but once I add, and by this I can just create a timing signal from this test bench program or this computer main file that I have uploaded. From here now I can see all the timing diagrams that's going to be here. So this is the latest file that I built. So now let's start with adding of the clock. So the clock is switching at every 5 nanoseconds. And now let's add sequence counter. So this is the sequence counter working at the first. So this first clock cycle is not going to work. So from the second post device, the sequence counter has started to work. And after this, let's put the memory out. Let's put the PC program counter output here. So the program counter is increasing accordingly. Now after the program counter, let's put MAR latch. MAR means memory address register. The memory latch enable is going to be a write enable in a memory latch. So basically what happens in the T0 cycle, in a positive is the value of PC is going to be inserted into the memory address register. So after that the MAR is written as 00 after loading it, and after the first clock cycle its output is changed to 00. And the process will happen from a bus that I have presented here. So in this bus, the bus selector is going to be 10010, which means selecting the program counter. And after that the value of PC will be loaded into the destination bus, and then the destination bus will take the value to MAR, and once the MAR latch is enabled, the value is going to be embedded into it. So that's how the first clock cycle, that means PC getting into MAR, will happen. And after that clock cycle the PC will be incremented, which we can see here. After this positive clock cycle, in this positive clock cycle the PC will be incremented by 1, and once the PC is incremented, the memory from referencing the memory address register, the memory will output the instructions. That means here at the this is the T0 cycle happening, this is the T1 cycle happening, and the output of T1 cycle will be shown in T2 cycle because it will be only effective after the positive age. So the memory is outputting 84, which was actually the first value that we put here. It was the hex of 10000100 is 84. So that's the memory read happening here. And during the memory read operations, the destination registers will be pointing the memory, and that's what it's doing. And also the memory output is set to 84. That means the value from memory output is actually on a destination bus output. Now once there is the output from memory, the IR latch should be enabled. New once the IR latch is enabled, its output should be 84 after this clock cycle. So basically the phase and decode cycle has just been cracked till here. Now as in my assembly program, the first operation was load. So for load, what will happen is for load operations, the first thing that will happen is first the PC is going to be okay. So rather than just me saying the thing, let's see the Verilog file what will happen at the load operation. So at the load operations, the destination bus will again be selected to PC, and the value will be again provided to MAR for fetching. So that's what is happening here. So here the MAR latch is enabled once the instruction is loaded and decoded at the load operations. So from that the memory output will output the actual output again, that is going to be here the memory output, that's E6. So memory is outputting E6, that means E6 means this value means E6. So basically the E6 value is outputted from the memory, and that value will get into the destination bus again, because that value needs to be traveled from destination bus to general registers. That's going to be R1. So let's see what's happening at the general register. So in general register, so basically we need to see here, so we can also see it from here. So basically here I have loaded R1, so the R1 latch will be enabled when I am loading the thing, right? So here the R1 latch is enabled, and the register output of R1 should be E6 from this clock cycle, and that's happening here. So after this, the first instruction is completed. So till here the load operations has been successfully completed. Now again the sequence counter is moved to 0, and the operation will take place again. So the second operation was also load, so the similar thing is happening here. In the second operations I have had loaded the value in R2 register, so R2 latch is being enabled here, and R2 output is D2, which means this value was loaded here. Now let's remove all of these things, or we can also do what is, we can just remove this destinations thing so that it will be clear, because the next operation is something that will be related to ALU. So let's do this, let's delete all of the available thing here. So I guess from previous two instructions we have got the idea that how the fetch and decode executions is going to happen, right? So now let's see what will happen in third operations, that means add. So add operation starts from here. So let me move my cursor here. So first of all, what's going to happen is sequence counter is in 0 0, PC output is going to be 4, because it's the fourth operations that's going to, this is the fourth memory address or fourth instruction that's going to occur, because the load operation is going to take two odd, because the load is two odd memory thing. So this 2 has been raised till 3. Now this is the fourth operation, so the program counter has raised to 4. So at the fourth place the IR latch has been enabled, and let's see the output of IR. So here the IR output is now set to, okay, just give me a second. So the IR output is set to 5 here. Okay, so this is going to, so this is what is happening. And once the IR is set here, now as the last operation was add in our assembly code, so it should be something related to ALU, right? So basically the ALU enable line should have been enabled at this stage. So basically at till here the phase and decode execution has been happening, and here the ALU is enabled. So basically if we also see into our control Verilog file, here when add is happening, the ALU is enabled, and source register to source will be selected for two inputs in ALU, and after that these are going to be the registers that we are going to be selecting, right? So for that, let's go into the ALU instance here, and let's see what are the inputs that are coming. So from input A, the E6 is happening, and from input 2 also E6 is happening, and the mode is 000, that means add, and the output will be CC, and I guess there would be flag carry too, and from here the flag carry is enabled throughout the system. So this is how the integrated system is going to work. Thank you. Sayonara matane.